Good evening ครับ everyone. I'm sorry for the delay นะครับ due to the technical problems, but I think we are ready now. Yeah. Um, um, on behalf of the Faculty of Architecture, Chulalongkorn University, it is my great pleasure to welcome you all to today's lecture series session. Today's lecture is entitled Code Your Leak, Big Your Code นะครับ Coding for Emotional Impact by อาจารย์ Nuntinee Tansrisakul นะครับ The main idea of this talk explores how everyday patterns can be observed, translated to generative rules, and then manifested in physical space so that logic transforms into tangible bodily experiences. This lecture invites us to be sensitive to mundane patterns and to think of coding not only as logic but as a means to create emotional impact through design. This event is a part of Architecture and Design for Society Academic Year 2025. The series bring together distinguished speakers from both Thailand and abroad across various fields of expertise to share knowledge, perspective, and research in architecture and design. For participants who are licensed architects and professionals, please note that your attendance today count toward CPD points. For students and participants who attend more than 80% of the lectures in this semester, you will receive a certificate of completion. This certificate can also be used to accumulate credits in the credit bank, which may be transferred if you later enroll in a program at the Faculty of Architecture. We would also like to extend our sincere thanks to Sakul Thai Company Limited for your generous support for the event. At this point, may I invite Assistant Professor Dr. Sarayut Sapsuk, Dean of Faculty of Architecture, Chulalongkorn University, to kindly deliver the opening remarks and to express appreciation to our speakers.
Good evening, everyone, and very warm welcome. On behalf of Faculty of Architecture, Chulalongkorn University, it is both pleasure and an honor to welcome you to our Lecture and Design for Society lecture series. This is a platform where we connect, learn, and find inspirations by bringing together speakers from different expertise, domestically and internationally, to share ideas that are shaping our world. This evening, we are excited to be joined by Ajahn Nuntinee Tansrisakul, a visionary algorithm composer and visual artist from New York City. Her work invites us into fascinating conversation between code and creativity, showing us how software can transcend its functional roots to become a powerful exploration tools for generative design. She will guide us through the process of transforming everyday patterns into generative rules, revealing how these digital and physical creations can deeply engage with and respond to our society. Before we begin, I'd like to extend our special thanks to Comdi and Comma for hosting this event and Ajahn Trump for guiding us as a MC today. Thank you all for being here. And before we starting, so please join me to giving a very warm welcome applause to welcome our guest, Ajahn Nuntinee, please.
Thank you so much for having me. Even just putting together this talk was exciting. So to be here and to be able to share my practice is such a huge privilege. So thank you. Also hi to all the familiar faces, including my friend who I haven't seen for 20 years. So hi everybody. Welcome to Code Your Lick and Lick Your Code. what does that even mean? I feel wrong for just putting the word lick on this giant screen with such a formal introduction. What do you think of when I say the word code? I have three associations. Code ภาษาไทยก็ได้นะคะ ตัวเลขค่ะตัวเลขมีอะไรขออีก2 อันโค้ดอะไรนะคะ language numbers language is interesting coding language one more impossible skill okay what about lick when I say lick lick. What's that? Intimacy. What else? Already you're seeing such a contrast between the two words. Lick. Ice cream. Intimacy and ice cream. Okay. So code is often seen as something very defined and rigid. Something that is absolute, such as a number, very formal and very in your brain. But when we think of the word lick, it is indeed intimate and very animalic, just like the cats and dogs we were showing earlier. And also it's a sensation of moving the mouth, and there's so much skin and so much saliva. These things are often seen as very separate and almost the opposite. But in today's talk, we are going to challenge this idea and say that these two are actually closely related, and that algorithms or code can actually help us discover emotions, this feeling of lickiness, or this feeling or new feelings. So how? As humans, this is the process of experiencing the world. So we see something, we see a visual, hear a sound, feel a touch of wind through our sensorial perception. Once we see it, we then try to recognize it as something. It becomes a thought. For example, I smell something, oh, that's a rotten egg. After it becomes a thought, it turns into an emotion or a meaning. Oh, that's a rotten egg, that's disgusting. So this is the process of us experiencing the world. There's a sensation, we try to make sense of it, and we try to give it a meaning. Here in my practice with code, I'm trying to stretch this cognitive process and play with how we can process information in order to widen our perspective and help us find new meanings or discover new meanings or new feelings. To modify the lens in seeing the world, and to see the same things as something that is truly different. I cannot turn this into something that is not water, but I am trying to see the water through a new lens using code. So how is coding related to all of this? When we talk about coding, it's such a loaded term. It can mean anything from a computer, computation, programming, software, machine learning, AI. But essentially, at the bottom of it, it is a set of rules and instructions to execute something. In creative coding or in my practice, oftentimes we don't know what the outcome is going to be, but we're trying to design this process in the middle to capture the input that is interesting, and the outcome is often a surprise. For example, if I were to have this water bottle here, if I did not code, I want to drink it, and I did not code, I would reach it, try to open the cap and drink it myself. If I were to code, I could ask, as an instructor, I could ask Ajahn Pap, please could you step down 2 steps, walk 5 steps towards me, hold up the bottle, slowly loosen the cap, and pour it into my mouth. And I could say, Ajahn Pap, repeat. And you could do it 100 times without me doing anything at all. So it's about having this ability to repeat, and therefore you're able to scale. So that's what coding means. And in my work, I try to design a framework or a set of rules, essentially an algorithm, to capture something interesting. Drum roll. First project, 0 to 99, public sound installation. So this was an installation I made in 2023 for TEDx Bangkok. This was installed at Hua Lamphong. So the installation is a large structure. Oops. With 100 voices from people aged 0 to 99, answering the same question of, if you could say something to your younger self, what would you say? The voices are arranged in this cylindrical structure, starting at 0, ending at 99, forming a complete continuous circle. Attendees walk in chronological order, some in reverse, others jumping to selected ages, but almost everybody stops at their own age. It becomes their reference point. So, as you may expect, there are patterns that people go through in life, and the things they wish to have done or wish to tell their younger selves. Starting from 0 to 10, it's like drink more milk, or sleep earlier, or eat yummy food. And as you age, it becomes more about studying, it becomes more about work, it becomes more about family, until you hit some sort of midlife where nothing matters anymore. You should just enjoy life, and then so on and so on. But the thing that surprised me even more than the patterns between the generations is the natural tone of voice that changes over 100 years. So it's not only the excitement for life or the contentment in life, but it is the textures of the voice. Because you're interviewing someone who is age 0, they could hardly speak a word. Or when they're 2 or 3, they're just getting exciting to string together a sentence. But when you get to the age of 90, you start to see that cycle come back in a different way. They find it hard to speak. They find it hard to form words. And their voices crack, and sentences become individual words. And so the moment where you go from 98, 99 to 0, you really feel the complete circle. And this circular form for this installation is completely key, because it is not something linear. It is not actually about 0 to 99, but it's about 0 to 99 to 0 to 99 to 0 to 99 over and over again. And that's the form that the circle lends us in this installation. So watching the attendees interact with the piece, there's a paradox between this individuality feeling of hearing just one person and this commonality being a single point in time at this like infinite whole. And everybody looks the same, you're just a dot in this installation. So the algorithm here is simple. We ask 100 people the same question, and it is the linearity that is such a contrast to us as humans. And you're no longer the center of something, but a dot in a larger space. tiny movies. Whoops. There's a little lag due to my hotspot, but what do you see in this image? Yes. Dogs. What else? What about the dogs? Are they different from regular dogs? It's a summer?
Because, I don't know, the shadow is very long.
The shadow is very long. What's that? They have white shadows? Do they have white shadows?
No. I don't think you've seen the top view.
They can be seen as having white shadows, or here maybe red shadows. Let's look at another one to see if we can see clearer. So this set of videos is one instruction. Everything here works in the same way. What do you observe about this one? Yes, the shadow is getting longer at the bottom. But why? How are the shadows getting longer at the bottom? It goes up. I think what's that? It's a little bit to do with time of day, yes. It is, so these lines that you see here are actually steps. But it's very hard to see in first person when you're walking up and down because it's so stretched, it's beyond your sight even. Because you're standing here, this is 33 steps. And so you don't have that vision. It just looks like a line of black. But because this imagery is from like 100 meters above, you get to see that shadows really stretch and contract. So we're very used to seeing, when we work in 3D software, the flat view of everything, and we can twist everything around. So this is a similar idea. We're looking at it flat from one angle, and so it feels like 2D, but it is actually 3D. So at this point, I was already like pulling my hair because I was confused by what I was seeing. This is the same idea, but this is definitely winter. This is of people at an ice skating rink. So when you're ice skating, you're seeing one person, the person in front of you, struggling to do something. But at this angle, you're seeing the interaction that is much larger. You're seeing the families here. You're seeing the person practicing here. You're seeing this person going round and round in circles. So your perception starts to shift when you're looking at something from a larger view. What can I do? What can I do with this idea? So I started filming everything at the park. So these are people practicing for ultimate frisbee, which is a frisbee sport. But it is actually just one pair. What I did was I stacked them next to each other and manipulated the speed. So they all start off at the same time. And then they perform this choreography that I programmed. So start in unison, and then slowly they change in speed. So you can see this choreography starts to form. And then they become still kind of in unison. And over time, you start to see this random pattern start to emerge. So the only variable that I'm changing here is the speed of the playback, but already I'm starting to get this very complex pattern that forms over time. Lastly, I hope there's sound for this. Oh. Let's see. Ooh. Oh, you can hear. Sorry, I have to turn this up, but it's going to be very loud. So 3, 2, 1. Okay. Hopefully we can hear this now. So let's watch this one more time, but try to figure out the algorithm in this. What do you think the instruction is? Any guesses? Yes.
Like walk into several steps in one direction, and if you the steps is like if you have to walk 10 steps, walk in one direction, and then it over, and then you came back and walk another 10 steps. And each person have a different kind of like coordinate or direction they have to go. And I think they'll have to see when will one of them clash, because each person have different numbers of steps. And I see that when someone like clash into each other, they have another like algorithms of equations they need to do. Like when they clash, are they solve it, and one person go another way.
Okay, so everybody is assigned a certain number of steps, and they walk for that number and turn around. And then if they clash, then they do something different. Oh no, this is a question. Is that what you're saying? Okay, very, 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 very close. It's missing just one thing. Well, it's a variation of that thing. What is it? Does anybody know what that instruction is missing? Yes. Oh, sorry. The certain note, exactly. So each person is assigned one note. And so at the beginning, the ticking is counting 3, 2, 1, and everybody goes. And they only turn around when they hear that note. And the hitting each other was just an accident. So they were deciding what to do when they were hitting each other. But the algorithm is very simple. You just walk forward, hear your note, walk back, hear your note, walk forward, hear your note, walk back. And with just that, this pattern is starting to form that is much more complicated. So all of these video series are above and parallel to the ground. And with this world view, it allows us to be just a little bit more objective. The next one is a strip. It is a video installation. This project began when I discovered this ISS live stream, or the International Space Station live stream. So this is live from space. I think that alone is crazy that we are seeing this and it is moving so fast. Like it feels like a time lapse because it is just larger than life. But with this, some facts about the International Space Station. So it flies at the speed of 28,000 kilometers per hour. Like, what does that even mean? It means it orbits the Earth roughly once every an hour and a half, so every 92 minutes. The speed, that is roughly 7.67 kilometers per second. So per second, I'm ready to Bang Na or something in 1 second. And with that information, I am also able to track. I'm able to see the live stream, but I'm also able to see exactly where it is on this map. Whoops. So right now it's flying just over here. So what we are seeing in this live video is right here. And so an hour and a half ago, it was just flying over like close to Thailand. And so sometimes you're able to see the coastal area when it flies over. But what is even more interesting is I found out after that, let me save that for later. This is the project that I came up with after finding the live stream. So I thought, how interesting would it be if I could see the Earth live all the time? Because I can see it, but it's just a tiny view of the Earth. I'm not seeing the actual planet. And so what I did was I took one strip from this video and stitched it together over time. And so I have this Earth strip that could technically be wrapped around in Sphere and continues to update, and I would have this globe, live globe view all the time, except for when there's signal loss. And so that's what I did. And this is, these are some of the images that came out of that algorithm. So this is South Asia landscape. It is so different to see these clouds from above, because usually when we see clouds, we're under its shadow, and it passes and it takes a really long time. And then you're feeling this faint cloud. Sometimes you're under the complete shadow, and sometimes you're in the sunlight. But here you're seeing the cloud from above, so the shadow is projected downward. And then I'm able to see something that is even larger, which is the patterns of the landscape, like all these mountains. Or this sunset across the Indian Ocean. So when we go watch a sunset, or when we do see a sunset, it's usually over a span of time. But with this algorithm, or with this thing, it happens so fast. This is over a span of a few seconds. This pink that we're seeing, that is supposedly the sunset, is just a few seconds. So it's like watching a time lapse, but it's not a time lapse. It's actually real time. And then you have this lobster-like pattern here that is the cloud. So the astronauts on the ISS see sunrise and sunsets every 45 minutes. This means they can see it between day and night 6 times a day within the 24-hour period. So that's kind of what we're seeing with the live stream. So this is the Australian coast, very blue. And this is the transition between light and dark. It happens very fast. So, this is the fun fact that I wanted to say. In our history, there's only been one ever photo of Earth that is captured in an instant, and that was in 1972. Everything else is a composite. Even the latest one, it's a composite of over 15 minutes of images. So it's really amazing that we have this live stream and we can see it in real time, all the time. And with this, again, I feel like it's a time lapse, and seeing the transitions of civilization and landscapes and clouds and moving through seasons in this borderless manner really makes me feel kind of closer to Earth, even though it's so far away, just because there's a sense of this instantaneousness. And it really makes me question the idea of distance and timescale. Because we're running out of time, I'm going to skip to my last piece, which is the variable cogs. This is a timepiece, and it is, let's watch it together. Sorry, I have to turn the sound up again. So if you would like to cover your ears. So 3, 2, 1. Okay. So we're going to watch this for 2 minutes. you can try to pay attention to the clicking. So let's watch it for 1 more minute. Okay. What was that? Any clues for this one? I'm very patient. So what you just saw were 4 clocks that move in distorted time, but snap back together every minute. So within the 1 minute, they go in and out of sync with each other, but always snap back together at the minute. So we think of a second as something that's absolute. But in reality, our experiences of time play out in very different forms. And they only really snap back together to a synchronized time, the time that is real for all of us whenever we look at our watches or our clocks. And so what you just saw, were 4 clocks with different increments in algorithm. So the first one was the real-time clock, so it's always moving in linear time. The second one was a sine wave, so it goes faster and then slows down, and then goes faster and then slows down. And the third one is a square wave, so it stops and then goes at double speed, and then stops and then goes at double speed. And then the triangle wave, which is always increasing in speed. And I also played with the random, or the noise. But actually what is interesting here is if you only focus on the numbers on the left, whichever one you look at can become your real time. So us as humans try to make sense of those patterns. And so we are attached to the change and make the change feel like a second, even though they are different. So in all these projects that I shared, the one thing in common is I'm only designing the process, not the output. And each has provided me with a different perspective to everyday life. And so to sum up this talk, we are designing a framework or a set of rules to capture something that is interesting. Oops. And this is my other summary of the talk. Oh no. Okay, so this talk is exactly 1 hour. We are at minute 53. So around here. So this is 1 minute, this is 1 hour. We're at about minute 53. This is 1 hour or a talk in a day. 1 minute, 1 hour, 1 day. This is a minute, an hour, a day in a week. So my talk is just here. This is a minute, in an hour, in a day, in a week, in a month. So thank you, everybody.
Thank you very much, Ajahn, for the extraordinary talk. We now would like to share the space to the audience. Would anyone has any question? We will do the Q&A session.
Yes.
Perhaps you could, it might be a bit personal, but how do you get into coding in the first place?
I was interested in how each person has a very different reality from each other. And the thing that we share in common, for example, I call this color yellow and you also call this color yellow, is this like training of pattern recognition that, okay, I'm training myself that, or my brain is training itself that this frequency means yellow and this frequency means orange. And so I realized that this pattern recognition system or this pattern generation system is very compatible with code. For example, with sound, that's the example for visuals, but with sound, certain frequencies sound pleasant, or certain frequencies together sound like annoying to the ear. And that all has to do with the symmetry of the frequencies themselves. And so I started to find these underlying patterns that shape how we perceive things. And so I was interested in code because it lends itself very well to the idea of computation and pattern generation.
Any other question?
งาน0 ถึง 99ใช่ไหมคะที่จริงมันคือไอเดียของแบบคอมพิวเทชันมากกว่าแต่มันไม่ได้ใช้แบบโคดดิ้งโดยตรงใช่หมายถึงว่าไอเดียของการที่มี instruction เดียวแล้วก็ทำทุกอย่างเป็น linear form คือไม่กระโดดเลยไม่เป็น0 30 15อะไรเงี้ยแต่ว่าทุกอย่างเป็นแบบเป๊ะทั้งหมดค่ะ Actually, a lot of the work is more the idea of the computational concept than coding itself. But I think it was very interesting to hear the answer about the choreography, the going back and forth choreography when you mentioned, but so the instruction alone of going and when you hear your note walk backward is one thing, but you really get into the concept of computation when you say, if you hit this, then do this, or if you don't hit this, then do this. And so that's when complex structures start to form. And I think that's the beauty in computation. Yes.
Thank you for your talk. It's great. I wanted to ask if you keep a sketchbook, or if you don't keep a sort of traditional sketchbook, what does your ideas process look like?
It's very, very messy. I think my sketchbook is like my downloads folder. Each program is technically called a sketch. I work, or in some software it's called a patch. And it looks like just lines of text, and then you hit run, and then the visual comes up. I need to sketch more.
So how you decide the outcome, like, because like the first project is installation, while the others are some of them are videos and some are like capture of images, collecting of image together.
The outcome comes later. I think this is where the word sketching might be the most relevant or appropriate. Is I come up with the process before the outcome, and it's usually adjusting this process to see the outcome even more clear and even more clear and even more clear. So with the first one, it's different because we were not sure at all what we were going to get, but we were really putting trust in the algorithm that this has to yield something interesting, because there are 100 people and have individual stories and are of different ages. But the thing that we designed and were very fixed with is there has to be nothing else. It just has to be a number, and everything has to be the same question. And so, yeah, the only thing that was designed was this like circular motion.
Thank you. I wanted to ask how much big of a part does randomness play in your process, and if you believe in random or if everything is not so random?
What do you think? I mean, what made you ask that question?
It's that part in the beginning when you especially said that about the accident in the process.
Mm-hmm.
And when I think of code, I think of systems or very calculated things when I do practice a little. But then in certain software, like for example on JavaScript, we can also add random as a parameter. Mm-hmm. And when it's, for example, people walking and see from a side, like they go from a point A to a point B, but so it's very regular in the tiny movies, but maybe sometimes they just walk in a way that is not conventional or something. They could.
Mm-hmm. how much does random play in my work, right? This is a very hard question because in the work, what I try to do is to recognize patterns from noise, right? And so it's almost like trying to filter out the random to make the pattern very clear. But what algorithms I use to filter out the random like dictates what's random or not. So everything is kind of random, and then you try to capture the non-random. So that's more like how it plays with the work. But if I were to really create a pure composition, like if I didn't have an input and I was trying to create music, I feel like random needs to be like a huge portion of it, because otherwise it's very predictable. Yeah.
Thank you for your insights. Thank you very much.
Thank you.
Is there any question more? Okay. I think, yeah, at the end of the talk นะครับ so thank you once again ครับ อาจารย์ Nuntinee นะครับ I think this is a very insightful, and the session really gives us new perspectives on the coding such, and the simple instruction can push us into the new space, new area นะครับ so thank you very much. Can we ask, sorry, can you please give allow applause to our speakers?